So I turned 31 some years ago, and my family did something I wasn't expecting at all. They got me a mug. Not just any mug, but a mug with my nature paper on it. Oh, so cute. When I tell you, I scream. I mean, who gets their scientific publications turned into a cup? Me. So, it reminded me of something important. We rarely pause to celebrate the work we've poured years into. So today, I want to share the story behind this mug, what my nature paper was actually about, and why it matters. So this gift from my family, people who watched me disappear into the lab for way too many nights, who heard I'm at the synchrotron way too often, who pretended to understand whenever I said Fiducial markers. They had no clue what I was talking about. To them, the mug wasn't just cute. It was a full circle moment. If you've ever worked on a long research project, you know the publication is one thing, but the journey, the setbacks, failed sample preparations, beam time drama, microscope breakdowns, that's the real story there. So when I saw this mug, I just felt grateful. Grateful for science, grateful for support, and honestly, proud of myself in a way I don't often allow myself to be. All right, enough of the chit-chat. Let's get into the science. Here is the simplest way to explain it to you like you're a 5-year-old. Biologists want to understand cells in incredible detail, not just the 2-dimensional pictures, but real 3-dimensional structures at nanometer resolution. That's like seeing 20,000 times thinner than a hair strand. Yikes. Different microscopes, however, they show us different information. Fluorescence microscopes, they can show you proteins and molecular structures. The what? Electron and soft X-ray tomography, they show you structures at high ultra resolution. The where is what they answer. So here is where it gets interesting. Combining fluorescence microscope and X-ray tomography or fluorescence microscopy is very, very difficult in 3 dimensions. This is because each of these microscopes use different contrasting methods, different temperatures sometimes, some at room temperature, some at cryogenic temperatures. And cryogenic, I mean, is minus 170 degrees Celsius. Yes. So, in this paper, we simply wanted a workflow that says, hey, here is how to prepare your sample so that both microscopes can tell the same story. As simple as that. So we focused on samples using cryo methods. These cryo methods employ fast freezing that keeps a cell in a natural, lifelike state. More or less, it's alive, but animated. Some call it suspended animation. So our paper did 2 big things. One, it compared multiple fiducial marker strategies. It's a fancy way of saying what tiny beads or markers should you add to both of these microscopes that can recognize them at the same point in a 3-dimensional space, depth. Number 2, we created practical preparation protocols, step-by-step workflows for scientists to follow, depending on their sample type and their imaging goals. AKA, what do you want to get out of this? So, we tested this protocol in 2 different countries, in 2 different beamlines. So, at the end of it, we got a decision matrix, aka decision aid. Ultimately, a cheat sheet that says, if your sample is like this, then use these markers. If your cells behave like this, expect this timeline. That's it. We essentially reduced trial and error for researchers doing 3D correlative cryoimaging. So, this research pushes forward the ability to study diseases at the cellular level, map infection pathways, understand organelles in 3D, and eventually apply this to more complex tissue types. Now, when I look at this mug, it's no longer just a birthday gift. It's a reminder of persistence. Science can be slow. It is slow. Always. Sometimes painful, often unpredictable. But the breakthrough, oh my goodness, the it worked moment and the impact our work can have on understanding life at the smallest scale. That right there, that's the reward. And if a mug can capture a little piece of that journey, I'll treasure it forever. Snuggle up to it. So, if you enjoyed this video, hit subscribe because I just want to share more moments like this. Not just the science, but the story behind it. Drop a comment telling me what achievements you are proud of but haven't celebrated enough. And if you want a breakdown of more research, microscopy techniques, or behind the scenes like this, let me know. Thanks for being here, and here's to celebrating our milestones, even the ones printed on a mug. Bye-bye, and see you in my next video.